So work in physics is defined as the transfer of energy into or out of a system. So work is basically saying if a force transfers energy into or out of a system, then it's doing work on that particular system. We can have positive work, we can also have negative work, and we're going to look at a couple of scenarios that are going to help us with the calculation of work and how we can manipulate that around. So in physics, we are saying work is the transfer of energy into and out of a system. But what is work mathematically? Work mathematically is defined as the product of the force of interest multiplied by the displacement of the object times cos of theta. Now let's break it down, where we can say our F is the force of interest, which is measured in newtons. Our delta X is the object's displacement, which is measured in meters. Theta is the angle between F, which is the force of interest, and the displacement, obviously in degrees. So work is the product of F, delta X, and cos theta. F is the force of interest, delta X is the displacement, and theta is the angle between the force and the displacement. Work is a scalar quantity which is measured in joules. So work is the transfer of energy into and out of a system, and this is the mathematical equation. So let's look at two cases. In fact, we're going to look at 4 cases. Let's look at them and how we can apply this work technique. So case 1, let's assume I've got an object, and on that object we are applying a force F, which causes the object to be displaced to the right. Now we want to find the work done by the particular force. A force F is directed on an object, causes the object to be displaced to the right. So let's find the work done. Our definition of work says that work is F delta X cos of theta. Now our F is F, our delta X is delta X. But what is theta? Remember we said theta is the angle between the force and the displacement. So our theta in this case, the force is parallel to the displacement and they are going in the same direction. So it means our theta is just 0 degrees, which means we will have work is equals to F delta X cos of 0, which simplifies to F delta X. Cos of 0 is just 1, so you just have a 1 there, which means the work done by this force is just F delta X. Now we can see that this force is doing a positive work. It means that this force is putting energy into the system, and that is evident because the object is moving in the direction of the force. So it makes sense for this particular object to be doing positive work on this particular system. Right, let's look at case 2. Case 2, let's put a case 2 there. So let's assume that on the very same object of mass m, the object was still moving or being displaced to the right. But now we are interested in a force that is acting in the opposite direction. Let's call that force frictional force. Now, what is the work done by this particular force? Again, our definition of work is F delta X cos of theta. What is our force of interest? Our force of interest is frictional force. The displacement is still delta X. But what is theta? The angle between F and the displacement. Our theta in this case is 180 degrees. These two forces are anti-parallel, and then the angle between them is only going to be 180 degrees, aka angles on a straight line. So we put a cos of 180 degrees there. Cos of 180 degrees, typing in our calculators, we get a negative 1, which means the work done by this force is negative and it's taking out energy from the system. So case 1 and case 2, very different, but we are using the same thing. So this guy is doing negative work. It means he's taking out energy of the system. So what is the conclusion between these two cases? This case, this force, if it's in the same direction as the displacement of the object, it's always going to do positive work. It's putting energy into the system. But this one, it's in the opposite direction. So it's trying to slow down the object. It means it's taking out energy from the system. That's why we said work is the transfer of energy into or out of a system.